Hello, everyone. Today we're going to be talking about SnAR, nucleophilic aromatic substitution. Why they're not called NAS reactions is beyond me, but essentially what we're going to need here for SnAR reactions, you're going to need a nucleophile, you're going to need an EWG, and then you're going to need a leaving group over here. And so we're going to go ahead and we're going to start off over here, right? We're going to attack onto here. Oh, you also need heat too, but a lot of reactions go that way. You're going to attack right here, and you're going to get the double bond in the ring onto this carbon right here. This carbon specifically. So I'm going to go ahead. I'm gonna dot this right there for you to see. And so you're going to go into the first step, which is going to be an addition step, which I personally like to call punch in. You punch into the reaction. Yeah. So you're going to get your Cl kind of just chilling here on its own. You have an NaOH here. We're just going to assume the Na just kind of pops off on its own, right? And from here, right, you're going to get a NO2 is going to be right here, right? So we'll go ahead and we'll write that out. I'm going to punch into the reaction. And then you're going to get a negative charge right there. Now from here, right, you're going to do some quick resonance. This resonance is going to pop. Oh my God, how do I draw this? It's such a small molecule over here. Negative charge rate. It's going to pop onto here. And then in response, this is going to pop up onto here. You punch in to the reaction. You're punching into the EWG. All right. Now that we have this reaction right here, a plus charge here. Gotcha. Ooh, I apologize, forgot to draw a plus charge here. Yep. Death by 1,000 cuts. I'm glad I caught myself. Right. Okay. And then from here, right, you're going to quickly do an elimination. Oh, sorry, let me just also resonance arrow. From here, you're going to do an elimination, and you're going to go to the next step. You're going to be punching out. And so I'm going to go ahead and draw this next step right here. Right, it's going to come down onto here. This is going to pop back onto here, and the Cl is going to and leave just like that. Okay, cool. This is your second step right here. Right here. So what did we just do, right? So we, right, the reason why I call it punch in and punch out, right, is because when you attack onto here, right, your electron, right, will bounce all the way up into the EWG via resonance, and then they will kind of come back down and punch their way out, and eventually out with it, right? You're going to have your leaving group's going to leave. Your CL is going to leave on its own. It's almost like if let's say for example you bought Amazon a package, right? And instead of opening it like a normal person, you just absolutely just punch into the box, right? Grab whatever you bought in there and pull it back out. And so that's kind of how I kind of envision these types of reactions, right? You use your NaOH or whatever nucleophile you have. You attack, you attack, you punch into your starting material all the way up your EWG, and then through resonance, right? You eventually do an elimination and you punch back out, right? And you remove your hand from the Amazon box, so to say. Alrighty, cool. The next one that we got going on here is going to be what I call special star or Cyclops SnAR, because it makes something that looks like Cyclops to me personally. But essentially, this is going to be just SnAR with a benzylic intermediate. And so you're going to form a benzyne, which is going to be like a ring that has a triple bond in it, right? So you have a benzylic. God, do I know how to spell? Benzylic intermediate. Is that even a word? We'll just call it benzyne. I've been calling it benzylic for a while, but we'll just call it benzyne intermediate. So nobody calls you crazy if you use that term. Benzylic. Anyways. So this can usually happen in the presence of a strong base, right? usually NaNH2. And so, see, the way this works, right? It's a little different, but it's not that different, I would say, right? So you have your first step is going to you're going to take your base, right? You're going to go and you're going to rip off an H right here. You're going to do a quick proton transfer, and then you're going to form your benzyne intermediate, benzylic intermediate, benzyne, whatever. You get the point. Right, so base time. I'm going to go through my little label here. So then you form this bad boy right here. Oh, hold up. Sorry. You form this right here. This BR stays here. And then from here, right, you're going to form your benzyne intermediate. So you're going to form this onto here. And this is going to pop off right here. You're going to end up with something along the lines of this. Right? That BR pisses off on its own, right? So this is your benzyne intermediate. And then from here, right, you're going to do a quick resonance rearrangement over here. Kind of going around the ring real quick. Then you're going to end up with this. No, let me just hide this so you kind of see visually if you're a little lost. Probably would help. Right? You're going to form what I think looks like a cyclops. Right? Alrighty. Cyclops. Right? Looks like a cyclops with its eyes closed. And my thing has crashed. Dang it. You know what? I should probably like restart my iPad. That just occurred to me. Oh well. We're already here so far now. So let me just go ahead and go over here, reshare screen. Okay. Alrighty. And then from here, you're going to go ahead and take another NaNH2. Right? So a second NaNH2. And you are going to attack onto here. And then this guy right here is going to pop up onto here. These electrons will go from bond to atom. So you're going to end up over here. And so, yeah, end up with this NH2 over here. Yep. And then you're going to go and use that NH3 finally that you had on the bottom of your reactants, right? Go into here, do quick proton transfer, and then boom, you end up with NaNH2. Yeah, you don't need to have an EWG. And oh my God, my iPad's on its last death rows. Oh my God, it's like dying. It crashed once more. Come on, dude. I have what? It's like you could have bought me like 30 seconds, dude. 30 seconds. That's all I asked. All right. Alrighty. And from there, right, you're going to form your final product. The H here. Yep. So you regain your H there. Some important things to know that both of these, right, are not SN2 reactions. So SnAR, SN2. It's more accurate to describe them as addition, elimination mechanisms. Why? Don't know, don't care. That's a PhD thing. So, alrighty, cool. So that's all the stuff I have for you today. Hopefully you guys are studying well, and I'll see you all sometime later.